Assalamu alaikum everyone. We are team 5 from second semester CSB. I am Sayyid Isnat Alam Bukhari and along with my teammates Umas Mirza, Sayyid Umar Mustafa and Sayyid Hadi Gilani. We are presenting you our topic proof techniques in discrete mathematics. Okay, so what is proof? What is a mathematical proof? Let's start with the basics, okay? What exactly is a mathematical proof? A mathematical proof is a rigorous step-by-step logical argument that shows a statement is true beyond any doubt. It starts from things we already know, like previous proven theorems and use of rules interference to reach a conclusion. So three important keys that makes our proof valid. Those are, we can say, it must be rigorous, meaning every step is justified. Logic, meaning it's based on definitions and accepted rules. And sound, meaning the starting premises are actually true and the reasoning is correct. Okay, and the basic flow about this concept is really simple. We start with a premise, apply logic reasoning, and arrive at a conclusion. So over here is our premise, then we apply our logic reasoning. It's our like 2 steps now, and then after that we go to a conclusion. So basically those are our 3 steps. And validity means the structure of the argument that we are presenting that is true. Okay, you can see premises, then reasoning, then conclusion. Okay, and after that we'll go to our next slide now. Okay, so the importance of proof. Okay, so the importance of proof. Now you might be wondering, why does this matter that for a computer science student like us? So there are 3 big reasons. First, algorithm correctness. Let's suppose we're using Instagram. They have their algorithm, okay? So to correct this, we actually use some of these rules. Okay, so the algorithm correctness. Proofs let us guarantee that an algorithm works correctly for every possible input, not just only one. Once we test it, which is critical for softwares, as I mentioned before, like Instagram. A lot of people in Pakistan use Instagram. Second, software reliability and security. Proof that backbone of cryptography that let us formally verify that our security protocol is safe and the software holds up against edge that attacks us. Thirdly, AI and logical reasoning. How like AI and logical reasoning actually integrates with each other, okay? So the proof techniques power automated reasoning systems in AI. Things like automated theorem provers, things like knowledge presentation system rely directly on their logic. Okay, and so we're gonna go towards our next slide. Okay, so the first slide is introduction to the rules of inference. Okay, so this brings us to the rule of inference. Things are logical laws that let us derive valid conclusion from given premise. Essentially building blocks of every proof. Like the blocks, they're built on top of every proof that we give to the software and algorithms. A quick note on notation. We use P and Q as propositional variables, okay? And the symbols like this implies, and this is for the and this for the or, and this for the not. The structure is same as before. We take our premise, apply logic to it, and arrive at a conclusion. The key guarantee is that if the premise is true, applying these rules guarantee the conclusion must be true. Okay? This is the foundation. Every formal proof is built on And in the next few slides, we'll go through the rules one by one, and Sayed Umar will come and describe the next rules.
Assalamualaikum everyone. My name is Sayyid Umar and my roll number is 2510271. I will explain the rules. As we know, the first rule we have is modus ponens. Now I will explain modus ponens, which is one of the most basic and important rule of interference in logic. Modus ponens tell us that if one statement implies another statement and the first statement is true, then the second statement must also be true. The symbol form is shown on the slide as P implies Q, therefore Q. To understand this better, let's look at the example given here. If it rains, then the ground becomes wet. We know that it is raining, therefore we can conclude that the ground is wet. Of course, if it rains, then the ground is wet. So this is basically modus ponens. This rule is very useful because it allows us to reach logical conclusions directly from known facts. In mathematics, computer science, modus ponens is used frequently in proofs, algorithms, and logical reasoning system. The important thing to remember is that if both premises are true, then the conclusion must also be true. Moving on, we have slide number 6, which is modus tollens. Uh, Unlike modus tollens works through negation. It states that if P implies Q, is true and Q is false, then P must also be false. The example on this slide help us understand this concept. If the alarm is set, then it will ring. However, we know that the alarm did not ring. Therefore, we can conclude that the alarm was not set. This method is useful when we know that expected result did not happen. By denying the result, we can deny the original condition that would have caused it. Modus tolerance is widely used logical proofs because it helps us eliminate possibilities and arrive at valid conclusion through reasoning. Now, moving on, we have slide number 7. On this slide, we can see some common valid arguments forms used in mathematical proofs. The first one is hypothetical syllogism. It allows us to connect two implications together. For example, if it rains, the ground becomes wet, and the ground is wet, it becomes slippery. Therefore, if it rains, it becomes slippery. The second form is a disjunctive. Disjunctive. Here we know that one of two possibilities must be true, and one option is false. Then the other option must be true. We also have conjunction, which combines two statements into a single statement. Finally, simplification allows us to extract one part from combined statement. These arguments forms are called valid because whenever the premises are true, the conclusion is guaranteed to be true. They are the foundation of logical reasoning and proof construction. Moving on, please, next slide. Now let's look at some invalid arguments for forms that should be avoided in proofs. The first one is called affirming the conquest. The example says that if it rains, the ground is wet, therefore it rained. This conclusion is not necessarily true because the ground could be wet for many other reasons as well, such as a sprinkler or spilled water. The second invalid form is denying antisented. Here it rains, the ground is wet. It is not raining, therefore the ground is not wet. Again, this conclusion is incorrect because the ground may still be wet from another source. This is called logical fallacies because they can lead us to false conclusions even when the premises are true. Therefore, when constructing proofs, we should always use valid arguments forms and carefully check whether the conclusion truly follows the premises. With that, we have covered modus ponens and modus tollens, valid argument form, and common logical fallacies. I would like to call next person to continue this meeting.
Assalamualaikum everyone, my name is Umesh Mirza and now I'll explain techniques of direct proof. A direct proof is basically simplest proof method. In this method, we assume that the given condition is true and logical steps are reached to require the conclusion. This process is very straightforward. Level number one, assume the statement that it is true. Apply the mathematical definitions or formulas. Number three, use logical reasoning, and last but not the least, it reaches the conclusion. We usually use direct proof when the path from assumptions to conclusion is clear and easy to follow. Next slide, please. Slide number two, direct proof and its example. Let's see the example of direct proof. The statement says if n is even, the n square is even too. First, we assume that like n is even. An even number can be written as 2n is equal to 2k when k is an integer. Now we square the both sides. You can see that since n square is divided by 2, it is also even. Therefore, we prove that n is even. Therefore, n square is also even. This is called direct proof because we started from the assumption and directly reached the conclusion. Next slide, please. Slide number three, proof by contrapositive. Now let's discuss another proof technique which is called proof by contrapositive. Sometimes direct proof is difficult. In such cases, we can use contrapositive instead. First statement, if P then Q. Its contrapositive is if not P then not Q. Both statements are logically equivalent, which means one automatically proves the other. The steps of contrapositive are like write the contrapositive, assume the negation of the conclusion. Number three, show the negation of the assumption follows. And last but not the least, therefore the original statement is true. This method is useful when proving the opposite direction is easier. Next slide, please. Example. Let's look at an example. The statement is if n square is even, then the n is even also. Instead of proving it directly, we can use contrapositive. If n square is odd, then the n is also odd. Assume n is odd. An odd number can be written as n is equal to 2k plus 1. Now we can take its square. This will become the form 2m plus 1, which means it is odd. So if n is odd, n square is also odd. Therefore, the contrapositive is true, and hence the original statement is also true. Thank you so much. I would like to pass further more slides to Sayyid Hadi Gilani.
Assalamualaikum everyone. Myself Sayyid Hadi Gilani and my roll number is 2510257. So next slide please, Hasnan. So there is an contradiction example here. तो अब हम यहाँ प्रूव करेंगे कॉन्ट्रडिक्शन के साथ और हम एज्यूम करते हैं कि जो स्क्वायर रूट 2 है ये रैशनल है, यानी कि अब a ओवर b की फॉर्म में हम इसको एज्यूम कर सकते हैं, मतलब लिख सकते हैं, जहां मैथमेटिकल स्टेप्स जो है परफॉर्म करने के बाद पता चलता है कि a और b दोनों इवन होने चाहिए मतलब। लेकिन हमने स्टार्ट में एज्यूम किया था कि जहाँ के हम यहाँ देख सकते हैं a is even, so let a is equals to 2k, substitute 2k square is equals to 2b square। अब हमने जब ये एज्यूम कर लिया तो हमें ये पता चला कि a और b दोनों इवन होने चाहिए, लेकिन स्टार्ट में हमने जब एज्यूम किया था उनका कॉमन फैक्टर नहीं है। ये कॉन्ट्राडिक्शन क्रिएट करता है, इसलिए हमारी एजम्पशन जो है ये रॉन्ग है और a स्क्वायर रूट इरेशनल प्रूव हो जाता है। नेक्स्ट स्लाइड प्लीज़। अब यहाँ पे कुछ रियल वर्ल्ड एप्लीकेशंस हैं इन प्रूफ्स की। तो जो प्रूफ टेक्निक्स होती हैं ये सिर्फ मैथमेटिकल टेक्निक्स ऐसी हैं कि ये सिर्फ मैथमेटिक्स तक बाउंड नहीं होती, लिमिटेड नहीं होती। ये हर फील्ड में इनका एक फीडबैक है, लेआउट है, ठीक है। تو اگر ہم سافٹ ویئر انجینئرنگ کی بات کریں تو وہاں پہ یہ الگوریتمس کی کریکٹنیس کو ویریفائی کرنے کے لیے یوز ہوتا ہے. ان آرٹیفیشیل انٹیلیجنس اٹ از آلسو یوزڈ اینڈ لاجیکل ریزننگ میں اور ڈیسیژن میکنگ کے لیے یہ بہت امپورٹنٹ ہے یہ پروف ٹیکنیکس. آفٹر دیٹ سائبر سیکیورٹی کی بات کریں تو ان میں انکرپشن اور سیکیورٹی پروٹوکولز کی ریلائبلٹی کو چیک کرنے کے لیے یہ ٹیکنیکس بہت یوزفل ہوتی ہیں. سو یہ ٹیکنیکس ہر فیلڈ میں تقریباً اپنا اپنا کردار ادا کر رہی ہیں. سو نیکسٹ سلائڈ پلیز. آفٹر دیٹ کمپیریزن آف پروف ٹیکنیکس ہے, پھر کنکلیوژن ہے. تو اگر ہم کمپیریزن کی بات کریں, ہم نے 3 پروف ٹیکنیکس پڑھی ہیں جن کے اندر ہم کمپیئر کریں. تو ڈائریکٹ پروف میں ہم کیا کرتے تھے کہ ہم ایزمپشن سے ڈائریکٹلی کنکلیوژن تک پہنچتے تھے. تو جو کانٹرڈکشن ہے اس میں ہم کیا کرتے تھے کہ اوریجنل اسٹیٹمنٹ کی بجائے ہم اس کی ایکولنٹ کانٹرا پازیٹیو پروف کرتے ہیں. ٹھیک ہے, تو جو کانٹرا ڈکشن ہے اس کے اندر ہم کیا کرتے ہیں کہ اس کے اپوزٹ اسٹیٹمنٹ ایزیوم کر کے امپاسبل ریزلٹ شو کرتے ہیں. مطلب یہ کہ ہر ٹیکنیک ہی یوزفل ہے, بس پرابلم کی جو نیچر ہے ہمیں وہ صحیح میتھڈ میں پتہ ہونی چاہیے. ٹھیک ہے, تو اگر ہم سلائڈ 4 مطلب کہ کنکلیوژن کی بات کریں تو ان کنکلیوژن وی کین سے دیٹ پروف ٹیکنیکس لاجیکل ریزننگ اور کو اسٹرانگ بناتی ہیں اور یہ انشور کرتی ہیں کہ اسٹیٹمنٹ کی کریکٹنیس کیا ہے اسٹیٹمنٹ کا نیچر کو جانتے ہوئے. ٹھیک ہے, اور یہ کنسیپٹس کمپیوٹر سائنس میں بھی بہت امپورٹنٹ ہیں, اور نہ صرف کمپیوٹر سائنس بلکہ ہماری لائف کے جتنے بھی فیلڈز ہیں سب میں تقریباً یہ ٹیکنیکس یوزڈ ہوتی ہیں. جی تھینک یو سو مچ, دیٹس آل فرام مائی سائڈ.
Okay, everyone. This is the end of our presentation. Hope you all enjoyed it. Please like and subscribe our YouTube channel.